Welcome all. So, Nikhil already introduced me, but a quick introduction about myself. I'm Parikshit, and one of my key focus area in Microsoft is I'm the program manager for Azure database for Postgres service on cloud, on Azure, right? I'm passionate about relational databases. I have over a decade of experience with relational databases. I was a program manager for storage engine for SQL Server code base. So this is where I spend most of my time in the relational databases, and I learned about it. But this talk is not about Microsoft or SQL Server or its products. It's about Postgres and distributed Postgres. But through the lenses of our learning, as we were investing and building our service, a world-class managed, fully managed Postgres service on our cloud platform. So I want you to keep that in mind as I go through this. In this session, I will talk about some of our learnings as Microsoft who were investing in Postgres, who were learning Postgres through our market research, as we were talking to customers who wanted to build solutions on the cloud, as we were collaborating with the Postgres community, and then how we are contributing back now to Postgres community as well. So without any further ado, let's get started. In India, we have a long tradition of worshipping elephant god, Ganeshji, right? It turns out now if you start worshipping Postgres elephant as well, called Slonik, right? You might see a lot of benefits as well. Clearly, Postgres, currently it's one of the most popular databases in the industry right now, and it's growing in popularity. Let me give you some data points to back this claim. In 2019 Stack Overflow survey, Postgres was voted as one of the most loved and wanted database in the industry. Further, if you look at DB Engine's ranking, Postgres has the claim of being the most popular database for 2 consecutive years, in 2017 and 2018. Further, if you look and drill down into the trend of Postgres and the popularity trend in the DB engines, you will learn that in the last 5 to 6 years, the popularity of the Postgres has grown steeply. If you compare it with any other relational databases in the market, you would see the popularity of Postgres has grown steeply. What it also implies is if you are a newbie in the Postgres area and if you're investing your career or skill set, now might be a good time. And if you're a business decision maker, if you're in a startup, if you're trying to invest and put your business or bets on Postgres, again, now might be a good time. This might be a good vote of confidence for end customers saying, okay, I think I can put, there are other customers also doing it. I think now is a good time for me also to consider it seriously. So why Postgres and why now? So again, as we were building this service in Microsoft, we were also curious about this trend to understand what exactly is going on behind the scenes. A 20-year-old product. So Postgres, by the way, is 22-decade-old product, was already there in the market for some time. In the last 5 or 6 years, why did developers and customers got attracted to Postgres, right? So let me share with you some of our learnings based on the market research. So what are the top reasons why customers or developers love Postgres? First and most important reason is it's truly open source. What do I mean by that? Not owned by a single owner or a company or an entity. It's truly community driven. The group of core committers across the globe are maintaining the code base, contributing back to the code base. So this is one of the primary reasons. It's a peace of mind. If you are an ISV, a startup, it's a peace of mind for you to put your bets on a product of like this, because then you don't have to worry about vendor lock-in, which means, hey, will my code work? Will there be any audits? Will there be any licensing policies? Will I have to go with only one cloud? So these are all the practical challenges which businesses face today, right? But being owned by a group of committers, you can be rest assured that, hey, I don't have to worry about all of this, and I can just simply write code and focus on my own business on Postgres, right? Now, if you look at the core design principles which were put together by Michael Stonebreaker and Lawrence Rowe 20 years back when they were writing about Postgres, thinking about Postgres. One of the core design principles for Postgres is user extensibility or extendability. This design feature is very powerful. It's a core principle which is very powerful and which allows Postgres or which makes Postgres very feature rich. If you think about Postgres, you have a variety of data types ranging from arrays, geometry, geography. You can store IP addresses as well as JSON-B capabilities. So and its highly extensible architecture makes it very easy for developers to build low-level extension on top of the database engine, which seamlessly integrates with the product. And as a result of this, Postgres becomes very versatile general-purpose database. You can use it for scenarios like NoSQL scenarios. You could use it for IoT scenarios. You can use it for geospatial. If you're working on location tracking, think about Uber, Ola cabs, right? If you're building those kind of apps where you have to use location data, Postgres could be a good option for you. So these extensibility in Postgres is what makes it a feature-rich database, which can be used. I would say, in a nutshell, it's a great general-purpose database. It's robust, reliable, and rich ecosystem. The fact that it is 20 years in the market also tells you that it is reliable and you can put your bets on it. And further, all the major development framework which you can think of Python, Django, Ruby on Rails, all of them supports Postgres. So this makes it very developer friendly. You don't have to go and search and reinvent the wheel. You're not betting on some product which is 2-year-old. It's 20 years old. There is whatever answers you're looking for might be already being discovered and posted in some of the forums out there. So it makes it very developer friendly in that perspective. Speed of innovation. The fact that it's community contributed, the turnaround for the bug fixes and innovations is much more faster. If you see, Postgres releases new versions with new extensibilities every year. So this is very valuable for developers and customers as they get the latest and the greatest features within a year or so. So this is very valuable for most customers. Finally, this can be arguable, but I think one of also the core reasons, if you see, of enterprise betting on open source databases is it's available as a managed service in most cloud providers. This is again a peace of mind for enterprises. They have a throat to choke. So who will provide the supportability? Who will provide the manageability? Should I be focusing on my business or should I be focusing on managing my database? So the fact that it's available in all the major cloud providers, that also makes it very portable. It is a common denominator, so you can't go wrong when you're betting on Postgres. So in summary, I think the sentiment which is resonating across the community is Postgres is clearly the new Linux of databases because it shares very similar characteristics, highly extensible, developer-friendly, enterprise bets on it, and I think that makes it a very great product for you to invest either your skills or put your bets from a business on Postgres as well. Now, let's switch gears a little bit to see what are the applications customers are building on cloud, or what are the common patterns of applications which are so-called cloud-native applications. Based on our learning, broadly we found there are three major categories of the cloud, three major categories of applications which are built by the cloud, built by the customers in the cloud today. First, multi-tenant SaaS solution. So if you can think about startups or disruptors in the B2B or B2C space are building software as a service application. Think about Salesforce, which was a disruptor in its market. Think about CRM applications. There is, if you are familiar with US, then there is TurboTax, which is a tax filing software provided as a SaaS offering by Intuit. So again, this tells you like there is high spend on some of these multi-tenant SaaS application, or there is more requirements for these kind of applications. Now, what are the common database characteristics which these kind of applications look for? They want the database to be able to store multi-tenant data and provide security and isolation. That's P0 or P, you would call it high priority for them. The next is the database should be able to linearly scale as the user adoption grows. So as they get more traffic, as they get more customers, the database should just transparently, linearly be able to scale. The second category which we have learned is real-time operational analytics. So with the growth of IoT technology and maturity of the data streaming products like Apache Kafka, Apache Spark Kafka, there is a need for real-time analytics solutions where businesses can take real-time decisions and build even ML algorithms to build like a self-healing system or predictive maintenance system, right? So if you, again, from the database context, if you think what are the major requirements of the databases for these kind of application? Fast, high-speed ingestion rate, because the telemetry data is coming pretty much not even seconds, it would be in milliseconds. So there is a high stream of data which will be coming in the order of milliseconds, and your database should be able to scale with this fast ingestion rate, and you are also running analytical queries across this data volume, right? So that is the characteristics of the database which is needed for these kind of applications. The third category of applications with e-commerce, with the growth of e-commerce and digital payment platform, another requirement is for the applications to have a hybrid transactional analytical system. What do I mean by that? Your typical systems, traditionally banking systems, were OLTP systems. You would build a separate data warehouse and extract the data, build ETL pipelines, and load the data. But now the new requirements, which are also dictated by the regulatory requirements and even the auditing requirements from businesses, what has happened is you need to run analytical query on the OLTP database. So you cannot afford to wait for it to land in your data warehouse. Think about credit card application where you want to do a fraud analytics. As soon as a transaction happens, somebody has to detect it to prevent the fraud, right? So that is the third nature of applications which we are seeing in the industry. So if you now quickly summarize the common theme of the database requirements across all these three type of application is the database should be able to support massive data volume, and it should be able to process this large volume of data. This is the common theme across all of this. So now switch back to Postgres, right? Let's see how is the Postgres parallel processing capabilities evolving over a period of year. So starting Postgres 9.6, this was the first time they changed the optimizer code to support parallel query plan processing. So, and then the new operators, query plan operators are being added so that they can support more and more parallel queries. What that means for you is, as you upgrade to the latest and greatest release of Postgres, and as you start scaling up, add more CPU to your server, you will start seeing faster query response time, and your workload will be able to scale, right? But then you will only be limited to certain extent. You will practically hit a ceiling somewhere when you are scaling up, right? You can go to 64 CPUs, 128 CPUs, 512, but at some point in time, you will max out. And inherently, in Postgres community version, natively, there is no distributed processing capabilities available out there. So this is one of the challenge which Postgres has today. And how do you solve that? Because the demand with the data explosion which you're seeing, the demand from the business and application is to scale and process like petabyte scale of the data, but you started small, but now you want to scale linearly and you want to scale on demand, and that problem is still not solved by Postgres. So this is one of the key things which you need to keep in mind is distributed Postgres is the need of the hour. because with the data explosion, you're seeing the kind of application patterns, you're seeing the kind of distributed computing power which is available for the application now. With Kubernetes, with cloud, you can think about the scale at which the application can scale, but the database has to scale as well. So how are we kind of thinking about this, and what was Microsoft's thought process about approaching this problem? So last year, we acquired a company called Citus, and this is the mascot of Citus. It's called Helicon. It's a combination of unicorn and elephant. So we acquired this company called Citus, which has built an extension on top of Postgres, which converts a single server Postgres into a distributed Postgres. And it's a completely distributed, scaled out architecture, which allows you to leverage the massive parallel processing capabilities which might be available in the cloud. And this allows you to linearly scale as your workload demand and your business requirement grows. One major important thing, Citus is open source. The code is available. The code is available on GitHub. You can go to citusdata/citus. You should be able to browse the code. You can send PRs. I'm sorry, I don't know why it keeps flipping. You can send pull requests, and you can also raise issues if you encounter any. And I promise I'm not doing this. All right, switching back. So Microsoft acquisition has not changed anything here. And again, I promise, maybe they like this slide more. I don't know why. I'll keep this for a minute. Okay, but the point is, Microsoft acquisition has not changed anything, and we don't plan to change anything as well. So in fact, in the previous slide, we are continuing to also, innovating the extension, and there is a monthly release cycle which we follow. So you will see pretty much new releases, minor releases coming out every month at least. And you would also see like the constant activity, because as we release our own patches for our own cloud version, we are parallelly releasing and innovating the community release as well. So there is no change there. One important point to keep in mind is it is not a fork. It still requires you to run on community version of Postgres. It still uses community version of Postgres, and this is different, and this kind of differentiates Citus from some of the commercial engines out there, which has kind of forked Postgres, but maintain Postgres compatibility. So if you think about this, you are still running on community version of the Postgres, and you don't have to be on Microsoft Azure to run Citus. That's one of the key things you have to keep in mind. So how does Citus actually shards the database? What is the secret sauce behind it? So Citus, what it does is it relies on the principle of partitioning or sharding. When you install Citus, you install a group of servers. You install a group of Postgres servers and with Citus extensions on top of it to form a cluster or something called as server group. Now, within a server group, you have one server which is given a coordinator role, and all the remaining servers are called as worker nodes, or they play the role of worker nodes. Your sharded data or distributed data resides on worker nodes, and all the compute processing happens on the worker nodes. The coordinator is again a Postgres engine, but it only stores the metadata about all the worker nodes, and it is the one which intercepts your queries. So with this architecture, again, if you think about it from a visual format perspective, if your application doesn't have to be changed. Your application will still write the same set of queries. It doesn't have to be aware of the Postgres worker nodes also. So it will fire the same queries, and you will hit the metadata layer. The coordinator, in turn, will fire a distributed query across all the worker nodes. The query will be executed in each of the workers, and the query will be executed in each of the worker nodes. The results are collated, and you get the results back. And the only difference here is at the time of schema definition, when you're creating database, at the time of schema definition, when you're creating the database, that is the time where you have to create something called as distributed tables and the reference tables. So this is where you define the key on which you are partitioning the tables, right? Sorry, I know it's annoying. I'll try to keep this as much away as possible. So let me show you a quick demo on how Citus can give you powerful scale compared to a single node Postgres, right? By the way, if you're not familiar, this is Azure Data Studio. Again, fully open source. We initially started it for SQL Server. We extended it for Postgres. And it's highly extensible, so anyone can add MySQL, other extensions as well. And again, you can use it if you are UI-friendly guy, you want to use a UI to connect to Postgres, you might want to check it out, Azure Data Studio. Again, a cross-platform tool, which means you don't have to be on Windows, you can be on Macs or Linux as well to use this. So this is Azure Data Studio. On the left side, I have single node Postgres with 1 million records. On the right side, it's a distributed Citus architecture. Again, a community version of Postgres running on 4 nodes, right? So let me show you the data. By the way, the schema is we have taken GitHub database and we have imported that in Postgres. In some of the data of GitHub check-ins is in JSON format, and the way we have partitioned the data in the Citus database is the data is partitioned by user ID. So every user, if you are a GitHub user, you're making any check-ins, you're doing any commits, all that is tracked in your own specific shard, right? So let's fire this query. So we have around 1 million records on this database, and parallelly, let me also fire this against Citus. So this query executed in somewhere 1 second. Let's see the count star query on the single node Postgres, somewhere around 12 seconds. So with 4 nodes, you can think, and again, it's no-brainer. You're just using distributed computing. You're spending, or you're throwing more hardware, and then you're distributing the query, and that is how you're getting all the results on 1 million record table, 1 million records table, right? Let's fire a bit more complex query. So this is an aggregation query. Let's say you are asked to run an aggregated query to identify what is the number of commits per hour, right, on GitHubs. Who are the top users who are doing more commits? So let's fire this query first, and then we can later see the execution plan as well. Yep, so this, in Citus, you would see the output is already here, again in 1 second. And here, somewhere again, around 13 seconds, right? And if you see in Citus, it's 1 second. Now, again, one of the beauty of Azure Data Studio tool, which we just made the latest release, is for you to see explain plan for Postgres. So quickly, if I want to see explain plan for the single node Postgres, here I'm just doing a scan, sort, and then group by, right? Now, if you see the distributed query plan with Citus, so see the difference here. The plan changes, and here, so, and this is 4 node. But you're seeing 32 because by default, when we create a distributed table, we create 32 shards. So that when you scale later, if you decide to add new worker nodes later, the shard just has to be copied. You don't have to reshard them or repartition them. The shards already exist. And 32 is a default number we chose, but you can go up to 128 shards also. So you can further scale out as needed. So this is the power of Citus. I showed you a very small demo with 1 million records, but imagine you want to work on petabyte scale of data, then you can just scale out horizontally, and Citus will do the trick for you. Now, the next obvious question you might have is, so who is using Citus? Is it production ready? Who are the top users? And we had the same question before we acquired Citus. We obviously, you want to evaluate the product, you want to evaluate the customers they have. And we found that we ourselves were the first customers for Citus. Our Windows telemetry system uses Citus data, Citus Postgres database to actually power the shiproom dashboard. So before Windows releases any patches, you have to see in the dashboard if it meets all the bars, if all the test criteria are successful, everything is green basically to ship a release. And this data is 1.5 petabytes. It's coming from 800 million Windows devices which is there. That data is collated, processed, and it's stored in 1.5 petabyte scale of Citus database. This database runs on 42 nodes, which means 42 servers, 22 servers each. So there is a HA, redundancy, but there is 22 node cluster, and the total aggregated compute capacity is 3,000 cores and 18 terabytes of memory. Again, this is the power of distributed architecture which you can think of. And the only reason it can survive and it can sustain this petabyte scale of the growth, and even we can add more nodes, because there is practically no limitation to add the nodes. So you add the nodes, there is a parallel, one more Postgres running on its own set of data, and you're processing the query. So you're architecting the data is important here, but then application doesn't have to worry about scaling and other needs. Again, we have a detailed case reference out there. If you want, you can further deep dive into our blog. And there is also a YouTube video from our principal engineer who worked on it. His name is Min V. And internally, that project was called VeniceDB. So if you search for VeniceDB Microsoft in YouTube, you might also come across that talk from Min on how he architected the solution. So with Citus, you solve the scaling problem. You solve the performance problem of your application. Now the Postgres can scale. You can harvest more data. The business is happy. But the problem now shifts into who can manage the data servers for you. Now you have a group of servers. Imagine if you were to be Min, you have to manage 44 nodes. So how do you manage this large cluster of servers? So that's your next operational problem. If you're a DBA, then this becomes your problem, right? So there is two options. One option, obviously, is you can run on a managed service on cloud, on Azure, right? This is where we make money, and this is our small commercial plug. But let's say you don't want to go with Azure. You don't want to go with Microsoft for whatever reasons you have. You want to be you want to continue to run on premises, or you might want to run it on different cloud. In that case, how do you manage the cluster? So our new best friend in the open source world to manage a distributed system is Kubernetes. As you would have all heard about it, Kubernetes helps you manage a large distributed system, like Citus as well, and that is how you can manage a large group of cluster. So let me show you a quick demo on how you can do this and how we have done this as well. So I have a Kubernetes installation on an Ubuntu VM. This is not your Minikube. This is if you have heard about Kubernetes in a Docker, it's using Kubernetes in a Docker. So it's a single node server, not running a massive scale out architecture, but it kind of gives you the essence of how you can manage using Kubernetes. So let me quickly. So if you see here, single node Kubernetes running 1.16.3 version. And what we have done on top of that is we built a client tool, a Python-based client tool called AZData, which allows you to manage Citus cluster. So you might have heard about Azure Arc. I don't know if you've heard about this, but Azure Arc is our vision for customers to run our products across any platform, across Microsoft Azure, on-prem, and the way this is possible is using the Kubernetes fabric layer. So Kubernetes becomes that fabric layer by which you can run it on any cloud. So if you were to run this on AWS, you might want to run it on EKS, you might want to run it on VMs, whatever works best for you. Same applies to GCP or other cloud providers as well, right? So you would use AZ data, and what you would do is create Postgres. I will provide the name of my Postgres instance which I want to create, the namespace in Kubernetes where I want this to be created, and the number of worker nodes I want to create. Let me start with 2. And it is asking me what is the data volume size which I want to provision. And again, there is no requirement for you to have, or there is no specific infrastructure requirement. You need any persistent store which gives you high availability. So you can choose to run it on S3, you can choose to run it on Azure Blob Store, whatever, again, works best for you. If you want a load balancer IP, we'll go with node port. And this, while this runs in parallel, let me show you what are the existing endpoints out there. So if you want to see what are the existing servers which I have installed,